Let's go over example 4 in this video for Math 261, Applied Calculus 1. And we're looking at this optimization problem. And this one is going to be a little bit tricky because we have to remember to use the quotient rule. I'm saying we have to use the quotient rule because Q of X is a quotient. It's a ratio. It's a rational function. So what do? I'm going to write down quotient rule. Fg prime is equal to g squared in the denominator, and the numerator is gf prime minus fg prime. And you're thinking, why are we doing the quotient rule? They're not even asking for the derivative, but listen, they're asking for maximum, absolute maximum, and absolute minimum in this interval from -6 to +6. -6 and +6, we're going to plug them in to Q of X to see which one is higher, which one is lower. But there is a chance that this graph may have a relative minimum or a relative maximum in between -6 and 6. So to find those, to identify these relative minimum and relative maximum, we need to find the critical values by finding the first derivative. And we're going to plug in those critical values into Q of X to see if it gives us the biggest number or the smallest number. So that is the plan of attack. So let us do the quotient rule. I'm going to identify all the pieces first. F being the top of the fraction, 4x. Then F prime is 4. G is the bottom of the fraction, which is x squared plus 4. And nicely, the G prime is simply 2x. I have all my quotient rule pieces laid out, so I can go ahead and put together my Q prime of x. The bottom of the fraction is going to be G squared. So G squared, that will be x squared plus 4 squared. Now go to the top of the fraction, start with G times F prime. F prime is simply 4. So now I'm multiplying that orange and the green highlighted terms. So that will be 4 times x squared plus 4. Draw the minus sign. Let's go to the part after the minus sign. I need to multiply f times, which is 4x, g prime, which is 2x. Now we're going to multiply the yellow and the blue. Yellow is 4x, blue is 2x. Haven't done this quotient rule in a while. Okay, so now let's simplify the numerator. If I distribute the 4 and multiply these two, the numerator will be 4x squared plus 16 minus 4 times 2 is 8. X times x is x squared. Alright, so I got everything out of the parentheses on the numerator. I can see that they have like term. If I do 4x squared minus 8x squared, that will give me minus 4x squared plus 16 all over x squared plus 4 squared in the denominator. So we found our Q prime of x. What do we do now? We're going to find critical values. Okay, so find critical values by first set Q prime of x equal to 0 and find where Q prime of x is undefined. Okay, I should probably take a look at my sentence a little bit. Find critical values by first setting. Okay, let's see. You see what I mean? Find critical values. Case number 1, where is this fraction equal to 0? Okay, let's talk about the case number 1, you guys. The fraction is equal to 0 when the numerator is equal to 0. Okay, when the top of the fraction is 0, then the whole fraction becomes 0. So to take care of that case, I will grab what was on the top of the fraction and I will set it equal to 0. On the other side, when is this function undefined? Where is this function undefined? A function is undefined when the bottom of the function is equal to 0. When the bottom of this fraction is equal to 0. So I'm going to have to solve both of these light purple and dark purple equation, and they will be my critical values. So let me solve the one on the left. If I subtract 16 from both sides, I get negative 4x squared equals negative 16. Let me divide both sides by negative 4. I get x squared is equal to positive 4. By taking square root of both sides, I will get the first two critical values are positive 2 and negative 2. Let me solve the one on the right where the function is undefined. If I take square root of both sides to get rid of that squaring, I will still get 0 on the other side. Subtract 4 from both sides, I get x squared equals negative 4. If you take square root of both sides, you realize that we're about to get something that is imaginary. So guess what? This function is never undefined. Non-real. So this function is always defined, so we don't have to worry about the second case of where critical value can happen. The critical value, the only critical values are positive 2 and negative 2, which makes the function 0. Okay, so I know my candidates. I'm going to see who is really the winner by plugging in 3 numbers, or 4 numbers is it? Now, hold on, let's take a look at this interval. This interval is going from negative 6 to positive 6, including negative 6 and positive 6. The two critical values that I just found is negative 2 and positive 2. Both of them are in this interval, so I have to plug in 4 different numbers into Q of x. I need to plug in negative 6, negative 2, positive 2, and positive 6 into Q of x to see which one gives us the biggest number. Because whichever one gives us the biggest number is going to be considered the absolute maximum, and the smallest one will be called the absolute minimum. Okay, I need more room over here. I'll do it over here. Okay, let me try to write very tiny. Okay, so what is Q of, let me start with the smallest number of negative 6, Q of negative 2, Q of positive 2, Q of positive 6. How small of a room that I have here gives me anxiety. Ugh. Alright, I'll try to write tiny. So the first case, we're going to do 4 times negative 6 divided by negative 6 squared plus 4. I'll go ahead and set it up, but I may just stop the video so that I can type this in the calculator and just give you the answers. But let me go ahead and set this up with you. 4 times, let me at least change the color because they're so tiny. This makes me upset. How little of a room that I have here. It's okay, no reason to be upset. Next one, if I plug in negative 2, I will get 4 times negative 2 divided by negative 2 squared plus 4. I'm going to have to change the notes next year so that my next semester students have more room. We are sacrificing. All right, next one. 4 times 2 divided by 2 squared plus 4. Now just set up one more thing, okay? Lastly, 4 times 6 divided by 6 squared plus 4. All right, I want you guys to type these into your calculators and tell me, you can't really tell me because you're not here, but we'll compare which number comes out to be the greatest and which number comes out to be the smallest. Let me pause this video, this recording, and then I'll type it in and I'll start recording again. So on the side, I have a calculator here. I type these numbers in and these are the values that I got. Let's go ahead and find the biggest number because the biggest number gets to be our absolute maximum. All right, which one is the greatest? 1 is the greatest, right? So this is the absolute maximum. Let's find the smallest number. Smallest number happens at negative 1 because negative 3 over 5, negative 3 over 5 in decimal is just negative 0.6, and this down here is positive 0.6. So they're not the greatest or the smallest. So we found it. Let's go ahead and fill in these blanks. Absolute maximum value is positive 1, and this happens at our critical value of x equals 2. Absolute minimum value is negative 1, And this happens at when x is equal to -2. At least our answers are the critical values, not the endpoints. But this one was a tricky problem, a little bit more difficult than the first three that we did, because we had to remember to use the quotient rule. And typically those rational functions, if the derivative is irrational, not only that the critical value happens when the function is equal to 0, but we have to also consider when is that first derivative undefined. So this one was a little bit longer, but I hope you understand what happened here. I will go ahead and stop this recording and come back and go over the very last one.